Good evening, and welcome to the Art Institute. I'm Jeff Nigro, a research associate and coordinator of the Boschel Foundation Lecture Series in the Department of the Arts of the Ancient Mediterranean and Byzantium at the Art Institute. And it's my great pleasure to welcome you all to this program, Pliny, Pigments, and Painters in the Ancient World, which is part of the Boschel Foundation Lecture Series. This lecture series is generously sponsored by the Boschel Family Foundation to present programs designed to stimulate interest in the art and archaeology of the ancient world. Although the Boschels could not be with us this evening, would you please join me in a round of applause to thank them for making these programs possible? Before proceeding with introductions, I would like to respectfully request that you ensure that all electronic devices and cell phones are switched off or silenced for the program, and to refrain from taking photographs or audio or video recordings during the presentation. Thank you. This evening's program promises to be a veritable Roman feast of information, because we have not only a distinguished guest speaker from whom we will be hearing shortly, but we also have two valued Art Institute colleagues who will join her later for a discussion focusing on evidence of the pigments on some of objects in the Art Institute's collections. An opportunity to pose questions to all three speakers will conclude the program. In the interest of time, I won't give our presenters the full introductions that they deserve, since you can read fuller bios of all three of them on our website. But I did want to add a bit more information here. I'm delighted to welcome our guest speaker, Dr. Hilary Becker, Associate Professor of Classical Studies at Binghamton University. A renowned authority on the colorful art of antiquity, Dr. Becker is currently working on a book about the economy of the ancient Roman pigment industry. And if you think that sounds like a dull topic, you're about to be proven very wrong. In her presentation this evening, Dr. Becker will address her research into the Naturalis Historia, natural history, by the ancient Roman writer Pliny the Elder, whose 2000th birthday we observe this year into next year. What can Pliny tell us or not tell us about the market for those pigments used for paintings, sculptures, and architecture that made the ancient Mediterranean world so vibrantly colorful? For the discussion, Dr. Becker will be joined by Dr. Giovanni Veri, conservation scientist in the Department of Conservation Science at the Art Institute. If his name sounds familiar, it could be because Dr. Veri has been the lead scientist on a project to rediscover the lost pigments of the sculptures on the Parthenon in Athens, and this project has recently been receiving extensive and glowing media attention in Smithsonian Magazine, The Guardian, and Newsweek, among many other publications. Acting as moderator for the discussion will be my esteemed departmental colleague, Dr. Catherine Raff, the Elizabeth McIlvaine Associate Curator of the Arts of the Ancient Mediterranean. Among other current projects, Dr. Raff is deeply engaged in a gradual refresh, as we're calling it, of the Mary and Michael Jaharis Galleries of Greek, Roman, and Byzantine art at the Art Institute, with a particular focus on the Roman Gallery under the direction of our department chair, Lisa Chakmak. This refresh will continue until the ultimate completion of that project in spring of 2025. As I mentioned, our distinguished guest will begin our program, so please join me in welcoming Hilary Becker to the podium.
Hi, and good evening. So thanks especially to the chemical revolution of the late 19th century, you can have virtually any color that you can imagine. But when we think about the Roman color palettes, what pigments they had available, it was much more restricted. So the Romans had pigments that were mineral-based, they had pigments that were organic-based, and they had one pigment that you'll be hearing about, which was synthetic, that was man-made. Now, and these pigments could be used in a variety of ways. You could use pigments in the Roman times to make cosmetics, you could use them to make medicaments, perfumes, but especially for paintings. And I started working on colors when I rediscovered the only surviving pigment shop in ancient Rome. And it's at the center of modern and ancient downtown Rome, just a few blocks from the Roman Forum at the slope of the Capitoline Hill. And here you can see some of the range of pigments that were discovered in this 3rd century to early 4th century AD pigment shop in Rome. I continued to do scientific research on these pigments with collaborators, and so I just wanted to acknowledge the support of the Soprintendenza Capitolina ai Beni Culturali for working on these amazing colors. Now, Pliny the Elder was one of my first guides as I started to research the pigments from this shop because his work provides important evidence for how ancient artists used their colorants. Pliny the Elder wrote the Natural History, the Historia Naturalis, around 70 AD. I'm going to provide brief information about who Pliny himself was, and then I'm going to share some of what he recorded so that help you understand what ancient Mediterranean artists might have known about their materials and how they might have used their artisanal materials. Now, Pliny's Natural History wrote in an impressive 37 books a lot of information about flora, fauna, minerals, astronomy, geography, and so on. Pliny's Natural History is a uniquely Roman document of the High Empire, and it kind of explains the world that the Romans understood at that time. Pliny's encyclopedia drew upon a range of Greek and Roman authors that came before him. And for our interest today, no other Greek or Roman author shares so much information about the history of art as Pliny did, particularly the development of sculpture and painting. And his work provides a portal to other authors, such as Alexander the Great's court artist Apelles, that do not otherwise survive. Now, as you were hearing, Pliny was born in 23 AD, or in the later part of that, or early 24 AD. So this year marks his 2000th anniversary, as we celebrate a text that was important in his own time, but also remained a seminal reference in the medieval and Renaissance periods. Pliny's birth is perhaps not as famous as his death, which happened in late October 79 AD. He was in charge of the imperial fleet stationed in the Bay of Naples when Mount Vesuvius erupted. And so he embarked on a rescue mission because he was an imperial administrator in charge of the fleet there, so it was his job, but also he was an insatiably curious natural historian, and he wanted to observe the volcano closer at hand. Unfortunately, too close at hand, and this unfortunately led to his untimely death at the age of 55. Pliny's Natural History is the most valuable ancient written source on pigments. He documented most of the pigments used in his day, listing their properties, as well as interesting facts about them. Notably, Pliny's sources had insight into how these pigments should be used, and so by reading the Natural History, we have the opportunity to read his account that allows us to know some of what Roman painters of his time actually knew about their craft. Pliny's insight can then be tested against surviving paintings to see if what he reported was actually true. So not only is textual evidence valuable for understanding ancient color and pigments, but increasingly, diverse scientific methods are being used to investigate cultural heritage objects, allowing us to learn more about these objects and how they came to be created. Science helps us to see colors which we might not otherwise be able to see with our own eyes today, and indeed, much of this color has been lost over the millennia. In many cases, scientific techniques make it possible to go behind the scenes of ancient art to understand more about how ancient Mediterranean artists utilized their artisanal materials. This makes it possible to compare what Pliny says about ancient art and colors to what science can tell us, and this is a profitable conversation. So I will now introduce you to a few of the colorants that Pliny included in his Natural History. The first pigment, indigo, is an organic blue pigment. Pliny knew that this pigment, which he called indigo in Latin, came from India, beyond the limits of the Roman Empire. Pliny gave a brief account of how this pigment was manufactured, and he was also aware that this pigment was expensive and that it could be adulterated and stretched out with cheaper additives. So Pliny shared with his readers a trick that would allow them to test if their indigo they were buying at the market was pure indigo or not. So Pliny's instructions stated to have that indigo and heat it over a fire, and once it reaches a certain temperature, it will produce a purple gas. So he writes, The mode of testing the genuineness of indigo is to see whether it emits a purple flame on being laid upon burning coals and the smell of sea while it smokes. I have replicated Pliny's litmus test with the help of chemists Gregory Smith and Victor Chen at Newfields Museum in Indianapolis, and Pliny's information was correct. So here you can see. However, it does not smell like the sea. So if ever, it smells like ammonia. So if ever a Roman did obtain this pigment, Pliny's tips could have offered them useful guidance for how to use it. Indigo has been found on the red shroud mummy known as Heraclides, now in the Getty Museum, and studied by Maurice Svoboda and Mark Walton. And indigo was also used on other wooden panels, long separated from mummies like this one, to which they were originally attached in the Fayum region. And you're going to hear more about this from Giovanni Veri in a little bit. So the indigo, you can see, look towards his feet and on the bird down at the bottom, was affixed to this mummy's wrappings using beeswax. Importantly, Pliny advised that when using indigo, wax was an effective binder. The painter working on the Heraclides mummy was using this expensive material in a way that Pliny would have approved of. Pliny also advised that indigo was not recommended for use when painting walls with the true fresco method, that is, on a wet lime background. In surveying painted walls from across the Roman Empire, indigo was usually not employed on these walls, and one reason for this is because it's incompatible with the most popular method for painting walls, and that's the true fresco method. It seems in general that Pliny's knowledge was practical knowledge and knowledge that artists also followed. And if an artist in Rome came across a material that was unfamiliar to them, such advice could help an artist use a new material with more efficacy. So, on from indigo to cinnabar. So Pliny also provided information for the expensive pigment cinnabar, mercury sulfide. While the red-orange pigment, cinnabar, is available in different places around the world, Pliny knew that this brilliant pigment was obtained in his times mostly from mines in Spain. Now, Pliny was always one to include interesting facts whenever he could, so he tells us that 2,000 pounds of cinnabar were exported annually from Spain, so that is a lot of expensive color for elite walls. Thus far, several samples of Roman cinnabar have been tested from Roman paintings in different locales, and all have been shown to have been originally sourced from Spain. And so for now, it seems that Pliny's information was correct. I'll also add that I'm currently involved in a project that's testing cinnabar sampled from across the Roman Empire to explore the historical use of this pigment and also see whether Pliny's information is as accurate as we think. So Pliny also shared some other advice about cinnabar, and this is advice that patrons and painters needed to know when using cinnabar. And that was, he told his readers that cinnabar was light sensitive. And the way he described it is that it's hostile to contact with light and moon. So it turns out, here you can see two samples of cinnabar from Pompeii, and you can see what that hostile light and moon can do to it. It blackens the cinnabar. That's one of the factors that makes this pigment vulnerable. And on another painting from Pompeii, the Villa of the Mysteries, you can see perhaps blackened parts of the background there. So Pliny not only told us that this pigment was vulnerable, but he also offered a potential preventative measure, and that was to lay wax over the cinnabar, hoping that that protective coat would have sealed the color in. And that's practical advice indeed. So gold foil and gold was an elite product, and only a little bit would have signaled elite status and a patron of means. It's not a pigment per se, but was used for elite decoration and was part of the polychromy, the decorating using multiple colors that the Romans particularly enjoyed. The Romans would likely have obtained gold from raw gold or pounding gold coins. And one other way that Pliny's source Vitruvius talks about is that you take recycled, worn-out fabric that has gold embroidery on it, and you burn it in a pot, and then you can extract the gold from there for reuse. So the artist in this relief, a gold beater, which in Latin is a bratiarius, likely knew what Pliny did about preparing gold foil. Pliny explained that 1 ounce of gold, 1 ounce of gold could be hammered into more than 750 leaves that were each 4 inches wide. In addition, we know from Pliny that there were 2 different varieties of gold foil, each with different thicknesses. These different types of gold foil likely had different market values, and thus Pliny is telling us something about the market and how it worked, and the choice that patrons and painters might have had, and this is something that scientific analysis can't tell us. So once you've hammered out the small leaves of gold, you're then going to carefully layer it onto a painted surface using a paste of cheaper pigments that would have both amplified the color and also served as an adhesive and or bind it using an organic binder like wax. Thus, Pliny's testimony gives us more information about how gold flakes were made, marketed, and applied. The Art Institute has 2 incredible stucco panels which are planned for future display. And if you're really rightfully intrigued by these, don't worry, you can learn more about them in the meantime from Dr. Catherine Rapp's incredible and free edited catalog on Roman art at the Art Institute, which is available online. So you don't even have to wait till 2025 for these. In the meantime, these panels were used as architectural decoration and had small details highlighted using gold foil. So on this side, you can see how Giovanni Verri has used X-ray fluorescence, which allows you to look at one element at a time. And you can see how on the upper right, gold foil was used to highlight the head of the winged woman. So that's panel 1, and here is panel 2. So consider also these 2 wooden panels from the Fayum region. Note that the one at the right, who's wearing an ivory wreath, is on display in the Ancient Arts of Egypt Gallery, which is on the lower level. These wooden panel paintings would have been once attached to mummies, such as the Heraclides mummy we saw earlier. The Roman Egyptian artists who decorated these Fayum panels used gold foil for the background and also for their wreaths. Scientific analysis of how the gold was applied for the panel at right by a team led by the Art Institute's Rachel Sabino revealed that straight and uniform gold leaves were applied one by one, and you can see the overlap of the strips of the gold leaves where the element gold has been detected using X-ray fluorescence again. So you can see how these gold leaves were applied and are even overlapping where the color is strongest. So scientific analysis like this allows us to understand more about how this painted portrait came to be created. But at the same time, Pliny provides insight into the manufacture and market for colorants like this. Some of the most naturally available and cheapest pigments available are iron-rich minerals such as red and yellow ochre. Here you can see a room predominantly painted with red and yellow ochre from Pompeii. This is the famous house of the Vedii. Now, Pliny recorded that if you heat yellow ochre can be turned to red ochre. And he says it's also made at Rome by calcining or burning yellow ochre, which is hard as marble, and quenching it with vinegar. Pliny, again, was absolutely correct. So in simple terms, when yellow ochre is heated, it loses its water and becomes red ochre. And as you can see from this slide demonstrating experimental archaeology, which here is explicitly explicating Pliny, the amount of heat applied affects the color produced, which can range from a darker yellow to red or brown or even purple. During the eruption of Mount Vesuvius in 79 AD, the towns of Pompeii and Herculaneum were exposed to sustained higher temperatures, where fires or even pyroclastic flows caused yellow ochre in some places to heat and changed its color, as you can see here in the upper portions of this wall at Herculaneum. So understanding what happens to yellow ochre in a way like this helps us to recognize that some paintings that are Pompeian red actually were once painted yellow. So importantly, Pliny the Elder is explaining that artists of his time made different shades of ochre by firing yellow ochre on purpose, and they were manipulating natural colors to expand their palette. So I want to think about the market a little bit more by focusing on red ochres. So Pliny explained that there were several varieties of red ochre coming from across the Mediterranean. So sites like southern Turkey produced a red ochre, there's one from Egypt, there's one from North Africa, there's another from the Aegean island of Lemnos. And these different varieties of red ochres had very different colors in some cases. Now, looking at this more modern mine in southern France immediately allows you to see some of the range of tones that red and yellow ochres produce. So this mine produces 9 different varieties of ochre. In the natural history, Pliny took the time to list a number of different varieties of pigment red ochre because these varieties are part of the diversity of the natural world that Pliny was interested in. He also shares this information because many of these red ochres had different handling properties. Not all red ochres could be used for the same commission. Further, Pliny shared that some of the different varieties of red and yellow ochres had different prices. So this again lets us know something about the choices that Roman painters had at the market. To this end, I want to show another object in the Art Institute's collection. And this is an Etruscan terracotta architectural relief depicting a battle between the gods and giants. This relief was made just to the north of Rome by artists living in Etruria, somewhere from the 3rd to 2nd centuries BC, so several centuries before Pliny lived. The colors on the relief are still vibrant today, and when you go to revisit this relief, look carefully at the reds. So start perhaps by looking at the giant in the middle, which has kind of an orange body, and it's a very different color than the maroon garment that the god at the left is wearing. So there's 3 different ochres, and there's also another red material. There's a red madder, which is an organic dye that was also used on this to decorate this relief. So from Pliny, we know that a robust market could supply different varieties of ochre. Now, whether these different varieties of ochre are coming from 3 different ochre mines, or whether these ochres were prepared differently, we don't know. But this gives us some idea of perhaps some of the choices that the Etruscan artists were negotiating with when they were making this relief. Now, while the artists in the ancient Mediterranean world potentially had more than one blue pigment from which to choose, the blue pigment that was predominantly chosen was the synthetic copper carbonate pigment known as Egyptian blue. Theophrastus, one of Pliny's favorite sources, had consulted for one of his sources the history of the kings of Egypt, and these histories talked about which king of Egypt first fused an artificial blue pigment in imitation of the natural kind. So which king first innovated Egyptian blue? So scientific analysis of a bowl from pre-dynastic Egypt, now in the Museum of Fine Arts, Boston, and dating around 3200 to 3000 BC, represents the earliest known use of Egyptian blue. So while the ancient source and this surviving bowl point to Egypt as the originator of the pigments that the Greek and Romans called Egyptian blue, we cannot decisively say where this pigment was first developed, whether that was actually in Egypt or the Levant or Mesopotamia. Thus, archaeology and science and text offer tantalizing clues, but not a distinctive answer. Now, Pliny stated that Egyptian blue was, quote, the blue pigment most especially approved of. And analysis of the blues that are used in ancient art, whether that's on wall paintings or sculpture or other surfaces, confirms that Egyptian blue was the preferred pigment across the Mediterranean cultures, as it had excellent handling properties so it doesn't fade with whatever binder that it was used. So these 2 Art Institute stucco panels that we saw before were predominantly painted in Egyptian blue. So it's the darker blue that you should be paying attention to. The lighter blue is modern restoration. One of the most exciting things that we've been learning in the last decades is that we are understanding more about how Egyptian blue was used. And this is in ways that we cannot see with our own eyes and in ways that Pliny could not have known to write about. Incredibly, Egyptian blue, when illuminated with infrared light, glows white. The bowl with Egyptian blue has an inscription in Egyptian blue, as Joachim Kahl demonstrated, and this inscription appears more legible, glowing in infrared light, attesting to King Scorpion. So was he the first king who made Egyptian blue? We don't know, but at least we can see his name now. Increasingly, scholars are shining selective lights and cameras on artifacts, revealing wide usage of Egyptian blue, more than we knew before, since only small particles of Egyptian blue can be detected in infrared light. In our discussion, Giovanni Veri will talk a little bit more about the detection of Egyptian blue and how this has helped him to understand more about the two incredible fine portraits in the Art Institute's collection. Now, Pliny the Elder did not share a stale encyclopedic list of pigments. His natural history contains real working knowledge that we can see used in practice by looking at ancient art, and especially by looking at ancient art with modern scientific tools. Not only am I saying that Pliny's Latin texts can meet painted objects and reveal things about the objects and their makers and their practice, but the other confrontation that I'm showing is that Pliny's text reveals various kinds of know-how, what Pliny knew, what the ancient artists knew, and that we can use that as a stepping off point to explore what we know about ancient colors. We can further use science as a bridge to explore knowledge that Pliny could not have fathomed, but Pliny's knowledge can still guide that kind of inquiry. As you revisit these objects in the Art Institute, think about how much of the color you can see with your own eyes. And think about how you can layer in a bit of Pliny's knowledge of the ancient pigment market and ancient artisanal practices. And then you can add in additional layers of color and praxis by thinking about what the science reveals. Tracing these colored materials and using Pliny, ancient art, and science together allows us to reanimate the ancient brushes of ancient artists. Thank you. So we're now going to pivot to a discussion of some of these topics and more, where I'll be joined by Catherine Raff and Giovanni Veri.
All right, well, thank you so much, Hillary, for that just incredibly rich and illuminating presentation just now, which has truly laid the groundwork for the discussion section of this evening's program. And so in the remainder of our time tonight, we'll be exploring just how Pliny's text, when combined with scientific research, can help us really just better understand and interpret ancient artworks, with a particular focus on specific works in the Art Institute's collection. Next slide, please. And so, again, I think, it's just such a thrill to hear from both of you and to be able to speak with both of you about this topic as truly authoritative scholars in the field. And so one of the things, as you've heard quite a bit about this evening, is the topic of Egyptian blue and blue pigments more generally, and this is definitely something we're going to be focusing on for part of the discussion. Not only how it's discussed in Pliny, but also in the ancient literary sources he's drawing upon, and how we encounter it in some of these ancient artworks. And just before doing so, I wanted to make just a few brief remarks about this work and a few related points about the research. One, just to note that our esteemed colleague Giovanni here is the scholar who developed the groundbreaking imaging technique that is used to identify Egyptian blue, to map its presence. And so I just want to point this out, just to let you know that when you're seeing these images, this is the person who has developed, this is the scholar who's developed this technique. So you're hearing from the real source of this. So, now, back to the actual artworks. As we've already seen in Hillary's presentation, there are certain works that have very clear visible traces of blue that can be seen with the naked eye, such as this truly fascinating Etruscan terracotta. And of course, this is an architectural relief, and despite how enormous it looks here, it's actually quite small in person. It's only about 18 inches tall, would have been on probably the roof line of a public building or temple, and so color would have been very important in helping make its subject matter more legible, and also might have carried a certain amount of iconographic meaning. And of course, and the next slide, thank you. Just to point out, you can actually, as Hillary already noted, go see this object for yourself in Gallery 151. And I really do, again, encourage you to see this in person to get a sense of the real traces of color that are very evident. And of course, here you can see the much smaller scale. So turning back to the object itself, I want to point out this object was the subject of a recent interdisciplinary study by Giovanni, myself, and our Art Institute colleagues Rachel Sabino and Clara Gronzotto to investigate the object's function and its paint layers. And so with that, because Giovanni in particular has spent considerable time with this piece, can you tell us a bit more about what we're seeing here and how scientific research helps us tell us that this is Egyptian blue?
Catherine. So yes, we definitely have visible traces of blue in the wing of the giant. That is very clear, and that is one use of the pigment. However, when we look at it through this imaging technique that highlights the presence of Egyptian blue as glowing white, we will see that its use is actually a bit more complex than that. So the areas of the wing glow white, which means there is a lot of Egyptian blue, but there are many other areas which glow white. And some of these areas include, for example, the dress, the mantle of the giant, as well as the dress of the female figure. And that is because Egyptian blue is not only used as a pure pigment to represent blue, but is also mixed with other pigments intuitively to represent, for example, purple when mixed with a red pigment. But interestingly, it's also used in the snake-like legs, which in fact had more of a cyan color. And this color is not really visible with the naked eye, but by the time sort of we look at it through this imaging technique, we can start drawing comparisons with other examples, such as this wall painting in Italy.
All right, this is from the tomb of the Typhon, so it's an Etruscan tomb from about the same point in time in which our architectural relief was created, so around the 3rd century. And of course here, just to Giovanni's point, you can see the very clear blue snaky legs on the monstrous snaky-legged giant here, so perhaps reinforcing the sort of serpentine nature of the sort of monster creature itself.
And now if we go back to the mummy portraits or funerary portraits we saw earlier, we can see different uses. And these are particularly useful examples because they are well preserved. These are paintings on panels and which would have been widespread in antiquity, but because of the climate, they only survive in desert, arid areas, so Egypt, for example.
And we are, as you've already seen, are fortunate to have 2 of these portraits in our collection. That was just one of them. And just to point out, too, that these are very interesting objects because they do come from, they were created in Egypt during the Roman imperial period and are really some of our best examples of painted panels from antiquity. There's about 1,100 that are known today, but they are part of this larger, rich tradition of panel painting that goes back to the Greek world, as you see on the left. This is one of very, very few examples from the Greek world of paintings that still survive on wooden panels. Much rarer, not necessarily from a funerary context, but we have this other painted portrait of the Emperor Septimius Severus and his family. And of course, so that is part of the Roman sort of portraiture tradition, where it's a focus on individualized representations of the subjects, and then combining all of this with the sort of Egyptian cultural traditions in terms of funerary practices of incorporating these types of portraits into the remains of mummified individuals. And so here, we're fortunate to be able to have objects like this that help us really see how painted portraits were carried out in antiquity. And again, of course, we don't always see blue in them, but sometimes blue is used in other ways. And I think this is, oh yes, thank you, sorry, got ahead of myself there. Just wanted to also kind of point out one more time to Hillary's, thank you for shouting this out earlier, you can also see one of the mummy portraits downstairs in the Egyptian gallery, so please do take a look at that now or in a future visit.
So you see here the mummy portrait when you look at it with the naked eye, and now on the right you see the distribution of Egyptian blue on the painting. And so immediately you'll see that there are some unexpected uses. For example, in the drapery, which is almost no longer visible to the naked eye, we can see that blue was used to highlight the folds, likely the more shadowy parts of the folds. So this is a sort of a new, sort of different use of Egyptian blue. But then if we look more carefully, we see that the blue pigment was also used within the skin tones, likely to achieve a more naturalistic appearance. So although not immediately visible with the naked eye, that little amount of blue was necessary to create that perfect hue that reproduced accurately the skin tones of the individual. And in this case, was used mostly on the upper lip, here, just above the upper lip, and in the area between the eyes, just at the top of the nose. This is another portrait, also in the collection here at the Art Institute, and you can see that a lot more was used for the skin tones. And if we look sort of across the use of these of this pigment in mummy portraiture, we can see that there were clearly probably many schools of practice in which they mixed pigments differently to achieve different effects. And we are naturally talking about Pliny, but all these sources are always looked at in the broader context. And it makes sense that a lot of attention was made in creating hues for the face. And so Plutarch says that painters get the likenesses in their portraits from the face and the expression of the eyes, wherein the character shows itself. Because there was clearly an intention, a function of the related to these portraits. Physiognomics in antiquity was a science, so to speak, that intended to represent character, moral values, and so on. But really blue, I'm continuing on mummy portraits, this use of Egyptian blue is very, very common, but it's not really the only blue pigment that was used in this way. We heard from Hilary earlier about the use of indigo, and in this instance, we have instead a different imaging technique called false color infrared, which shows the presence of indigo as bright pink. So you immediately see that pink was used here in the decorative band on the tunic, but also here on the mantle, which is draped on the shoulder. And so this is just a detail to show you that indigo here was used, again, probably to highlight the presence of volume in the drapery. And going back to Pliny, this is an interesting passage because Pliny tells us about what he calls incisures. He says that it is not long since that indigo began to be imported, whose price is 7 denarii. Painters make use of it for incisures, that is, the division of shadows from light. So in this sort of difficult process that people like Hilary, we try and interpret the primary source evidence with the archaeological, scientific, technical evidence. So is perhaps what we have just seen an example of an incision? Perhaps. He also tells us that there is another type of pigment called lomentum, likely Egyptian blue, which is known to us as ground. And this is not very expensive, and it's probably because it's a sort of ground up and inferior quality, so to speak, Egyptian blue. And it's interesting to notice, right, Hilary, that immediately after this passage, Pliny tells us something special about indigo, right?
Yes. So what Giovanni is talking about is, so there's a lot of people who read Pliny's Latin, but when you're reading Pliny's Latin and you're doing experimental archaeology or you're looking at the science, sometimes you look at the Latinity that Pliny uses and you might have greater insight into what's actually going on. And so a lot of us have seen the word incisuras that Pliny uses, which means either kind of something that's been cut or dividing lines. And it didn't jump off the page for me. But as Giovanni has been looking at so many and bringing these colors out, all of a sudden the Latin that Pliny uses makes sense. It seems that Pliny's using a technical term that probably these very artists were familiar with because they're doing that thing. So I think you've unlocked it for sure.
We will see. There is also another example. This is a mummy portrait in the collection of Susan and Lou Manilow, who have kindly allowed us to investigate. And you see in this area here, again, a mantle draped around the shoulders. And so if we look at the detail, this detail here, we can see that there is a shadow, that's dark part here, and then there are brighter highlights here. Okay? So this is supposed to be the fold, the deepest recess of the fold. So now, when we look for Egyptian blue, so in this area, and here is a detail, we can see that in fact the dark area here, the darker area, contains large amounts of Egyptian blue. But when we look at it in detail, we can see that this is not really blue nor white. It's a sort of a translucent layer. So perhaps it could be another interpretation of what we read in Pliny about these incisures, the transition between light and shadow. And so perhaps this veil on top of the shadow that goes across the highlight and the shadow perhaps is made to create a more homogeneous appearance and more naturalistic appearance of the drapery. But as you can see, all these are interpretations. We are just trying to look at as many case studies as we can to try and go back to Pliny and other authors and interpret what they say.
Can I ask you both, does Pliny use that term anywhere else? Or I don't think we talked about this, but is this the sort of, from what you're aware of, the one instance of this term being used?
Yeah, so he talks about things being incised. He talks about plant leaves being incised. But when he uses this term, he defines it. So he's using it in a discretely different way. And maybe he's assuming his readership doesn't know, but needs to know.
Do you think that he got that term from an earlier source, or do you think this maybe is something that he's observing from?
Absolutely. So Pliny is reading the manuals from artists, and I think he might be borrowing that for sure, because it seems that you've found them.
He explicitly says that the Greeks have written many books on materials and also what we would call today art history, techniques, how to apply pigments. So it's clear that he's drawing from many sources. It's up to us to disentangle them, because most of these sources, the sort of earlier sources, do not survive. The ancient Greek treatises do not survive.
Fantastic. Well, I think being mindful of time and making sure that we leave time for questions, I just wanted to thank Hilary and Giovanni again for this, just not only Hilary for your fantastic presentation, but just for this enlightening discussion about Pliny and pigments and painting techniques. And of course, we've only had time to just scratch the surface on this topic this evening, but I think that one of the key takeaways from this discussion is very much that reading and interpreting Pliny's text and how it relates to materials and techniques used in creating ancient artworks very much requires an approach that just goes beyond simply reading the Latin text. And that I think you can see just from both of our esteemed colleagues here that we very much need to take an interdisciplinary perspective with this, not only pulling from scientific fields, from physics, from chemistry, geology, but of course from archaeological and art historical research. And that we really do need this kind of multi-pronged approach of going back and forth between the sources and the objects that will help us continue to build our knowledge, not only of the diverse use of colors in antiquity, but very much, as Hilary has been really stressing here, what ancient artists really knew about their craft. And I think finally, just from a museum standpoint, this is something that, of course, can certainly enrich and enliven our presentation for our audiences. And we very much look forward to finding new ways to share these developments on these works in the Art Institute's collection with you in the near future. So thank you. With that, I would just like to thank Hillary and Giovanni again. And how many questions, Miguel, do we maybe have time for?
Yeah, so we have about 10 or 12 minutes, so time for plenty of questions. If people could just raise their hand, we will get you guys a microphone, and you'll be able to ask your question. We actually have one right here.
Hi, thanks so much for your presentation. Is there a way to figure out what these objects actually looked like at the time? Like, I'm thinking about that king scorpion bowl that you showed that looks white now, but it had Egyptian blue on it. Do you have a way to approximate what these objects actually looked like?
An example like that, there are, coming from an Egyptian context, has parallels, so to speak, although that is particularly early. But hieroglyphs or signs incised and filled in with Egyptian blue do exist and can still be seen with the naked eye. So in general, they would have looked like inlays. One example is the sarcophagus of Seti I at the Sir John Soane's Museum in London, some fragments of which survive both in Egypt and also at the British Museum. And you can clearly see this paste added to the hieroglyph, which looked like an inlay, a blue inlay. Sometimes, as it happens also in the sarcophagus of Seti I, and possibly also in the cup that we have just seen, there is alteration, losses on the one hand, and alteration, not often of the Egyptian blue, but often of the binding medium that can alter its color and turn yellow-brown, giving a very different appearance to what we see today.
So if I could also just telescope out and talk about, once we have, now that we have diverse scientific techniques to recover color that is now lost, so Egyptian blue, you can just see fragments smaller than the human hair and allow us to see what might have been there but is long since washed away. Once we have that power, then the question is, what do you do with it? So the Brinkmans, starting in the 90s, have been reconstructing ancient art and helping us kind of understand what these colored objects would have looked like. So the Chroma exhibit at the Met last year was focusing on that. So that definitely might be a next starting point if you want to explore that.
Yeah, certainly in a Greco-Roman context, especially for sculpture, the problem is larger, so to speak, because much less evidence survive and very little comparative material survives in good enough condition. On sculpture, if we're lucky, we find microscopic traces. So the extrapolation of that evidence from microscopic traces to a full-blown reconstruction is a task fraught with difficulties. And so the study of objects such as this one, but also of objects like the mummy portraits, which are so well preserved, are extraordinarily important because they serve as a term of comparison to understand what was happening at the time, which may inform how to reconstruct, so to speak, the original appearance, which will likely always remain elusive until something, perhaps from Egypt or Northern Africa, will one day resurface in an archaeological context that will be well preserved enough for us to really see what these sculptures looked like.
Yes, I have two questions, and they're related to each other. And my first is about the Greek sources for pigments that you referred to. And also tied in with that is I was reading recently about how the Greeks' sense of color is much different than ours. And so trying to interpret a phrase like Homer's wine dark seas had to do much with their sense of color, had to do with the effect of light on different objects. And I wonder how that ties in with your work.
Yeah, so in terms of color, we have two great sources on pigments. So Theophrastus, writing in the 4th century, who's writing on stones, and that is one of Pliny's sources. And then we have Dioscorides, who's writing at the time of Pliny. They have similar sources, but they don't seem to know each other. He's talking about medical materials, but some of the medical materials are pigments, so we get a lot of free information. And his texts also survived into the Middle Ages and remained seminal reference points. So if you're into Greeks and colors, I highly recommend looking at Aristotle, who explores many layers of it. That's another source of Pliny. So these are sources that Pliny's looking at that we have, so we can then compare them with great profit. Homer, there is, of course, a lot of scholarship there, and it's not that Homer couldn't see color. He's a poet, and so he's talking about, he's focusing on different things. So he doesn't use the term blue, but it doesn't, I think the wine dark sea is much more evocative.
I have a quick question about the painting analysis you've done on the Parthenon, and wondering, would that painting have mostly been done in situ after all the marbles were already established on scaffolding, or would any of that have been done before those friezes were placed up on the Parthenon? Any idea on that?
Yes, the evidence points clearly to having been painted, fully painted, sculpted, of course, and painted prior to their installation on the bottom shelf of the pediment. And that is because the paint is found at the back of the sculptures, and a lot of it. And so in areas which would have not been accessible afterwards. So that is, it does answer your question. It also tells us that these areas could not have been later restorations, say in Roman times, to refresh the sculptures, because we know that this was happening at the time. Because again, these areas would not have been accessible. And we can only speculate as to why they would paint them at the back, where they were not meant to be seen. So just to give sort of quick answers, the one option would be that, these are gods and goddesses, and so out of respect, they had to be painted and sculpted and painted in the round. On the other hand, we know that Pericles was showing around, so to speak, VIPs to look at the great works. So sponsors and so on, patrons, would have wanted to likely see beautiful, complete sculptures rather than things only painted on one side. And also from an artistic perspective, perhaps the artists needed to have the full round completed. But all these are sort of speculations, of course.
Katie, we have time for one more question.
Okay, great.
Going through the kind of painting analysis that you all showed using infrared scanning and also kind of on the indigo as well as the Egyptian blue, I was wondering if that kind of extends to more pigments, or if right now that research is just kind of based in those two pigments, or do we have technology right now where you can kind of see other hues and other pigments?
There are some. Hilary showed the X-ray fluorescence that allows us to see the presence of iron, which points likely towards the presence of things like ochres, the presence of lead that can point us towards the use of pigments such as lead white or red lead. However, a lot of these techniques, so that there are are options. Vanadium for vanadinide. So scanning X-ray fluorescence is becoming particularly helpful and is being developed in these years, really. It's a very recent development. Or at least it has become now much more widely applied than it was before. And there are things like ultraviolet luminescence that helps us see some of the organic red colorants or yellow colorants as well. But yes, there's a lot of research in trying to find different ways to visualize different materials. An interesting point is that some of these techniques are more easily applied than others in terms of imaging distribution maps, of course. And so the one, for example, with Egyptian blue, the natural response of Egyptian blue is so strong and so easy that it's very, very easy to capture. Macro X-ray fluorescence scanning requires, as you can imagine, an instrument that is bulky, large, difficult to transport, expensive, blah, blah, blah. So it's more difficult to get the high numbers of case studies that we can have instead with things like ultraviolet or infrared.
And I will just add that increasingly there are more tools that you can take into the field that are portable and non-invasive. And so if you're only using one, so X-ray fluorescence is amazing and can detect many pigments, but not organic pigments, right? So if you can use a wider toolkit, we can increasingly sample more things, increasingly for less expense. And again, it pays to have friends that are chemists and physicists that will loan you equipment or go along with you. And it used to be you had to take samples of things, and now increasingly we don't have to do that for most techniques. And so we're learning more, and that also helps us protect these walls and surfaces better too if we understand what they're made of.
Yeah, and these techniques also help in informing sampling, because of course this technique can tell us a level of information, but we're not there yet where we can sort of do away with sampling. Sampling is necessary to answer specific questions. But we want to know where to take the sample. So these kind of investigations help us inform a sampling strategy that will then meaningfully answer the questions that remain outstanding. And one typical is the binding medium. We know very little about binding media in antiquity.
Well, let us do another round of applause to thank our three speakers this evening. Thank you. Thank you all for coming this evening, and enjoy the rest of your evening. Thank you.